Hi, in this video we're going to continue working on solving trig equations, section 1 of chapter 5, and this is video part 2. In part 1 we did an example where we had an equation, we equaled it to 0, factor, then solved. Now let's take a look at this second example and compare it to the first and see what's different. So first of all, if we want to equal this to 0, we have to subtract 1. So 2 sine squared x plus sine x minus 1 equal to 0. So we equaled it to 0. Second step, we should think about factoring. In our first example, just a quick reminder, we got to a point where we got cosine cube of x minus cosine x equals 0, and we said the common factor was cosine x. We factored using the common factor. If we look right here, we can't find a common factor for all three terms. Yes, sine is common for the first two terms, but it doesn't help with that -1 right here. So this is why we cannot factor using the common factor. This should look familiar, but if it doesn't, I would highly suggest you just use S for sine. And that way you can see this equation better. This equation should remind you of solving quadratics. And we solve quadratics either by factoring using a common factor, which is not the case right here, or factoring using the x method, and that's what we're going to use. So reminder about the x method. A multiplied by C goes on the top, and B goes on the bottom. You need two numbers that multiply to AC and add up to B, and it's in the form of ax squared plus bx plus c equals 0. So in this case, let's apply it. A equals 2, B equals 1, C equals -1. A times C is -2, B is 1. We need two numbers that multiply to -2 and add up to 1. And in this case, we get 2 and -1 because we want those numbers to add up to a positive. So the bigger one has to be positive. And we get the factored form, which is in this case, it's not x, but it's s plus 2 and s minus 1 equals 0. This is the factored form. The only thing you need to remember is if your a is not a 1, which is the case right here, a is not a 1, a equals 2, you must divide by a. So I'm going to have to divide by a. So I'll get s plus 1 into s minus half equals 0. And remember, s refers to sine. So sine of x plus 1 equals 0 using the zero product theorem right here. Taking each factor and equaling it to 0. I get sine x equals -1. And if you take this equation, you should get sine x equals half. At this point, I'm going to ask myself which angles have a sine, angles have a sine equals a -1. Sine is the y coordinate, and 3 pi over 2 does have sine equal -1. Which angle or angles have a sine equal half, y coordinate equal half, 4 pi over 6 and 5 pi over 6. So I'm going to write this down. I get x equal pi over 6 and x equal 5 pi over 6. And those are the three solutions to this given equation. Now, to practice more, complete page 411, number 51 through 56. One thing I would like to tell you is keep in mind you're going to try to equal the equation to 0, factor, and solve using the zero product theorem. But remember from our first example from video part 1 that sometimes you have excluded values, restrictions. In this case, we don't have any because we don't have a fraction. We don't have a denominator. We don't have a problem. Usually restrictions come with either a fraction, a square root, a log. But in the case of trigonometry, when you see a tangent, cotan, secant, cosecant, you should also think about restrictions because by itself, tan is a fraction. Similarly, cotan and the other two functions. So we know that tangent is equal to sine over cosine, so it does have a denominator. And the denominator is not allowed to be 0. Which angles have a cosine equals 0? The x-coordinate, pi over 2 and 3 pi over 2. So whenever you have tangent, in a problem as you're solving, keep in mind you are not allowed to get pi over 2 or 3 pi over 2. And that's the case in 52, 53, 54, 55. If you have a cotan, and let's change the color. We did have this problem in part 1. It's cosine over sine. The sine is not allowed to be a 0. So the two angles that get a sine equal 0 are 0 and pi. So whenever you have a problem, an equation that you need to solve, and the equation includes a cotan, you should keep in mind the restricted values are 0 and pi. If you are solving and the problem includes a tangent, the restricted values are pi over 2 and 3 pi over 2.